Okay, now we're looking at number 6, a simple proof here. Complete the proof with the proper reasons. When we look at what's given, it says triangle ABC is an isosceles triangle where AD, segment AD, is perpendicular to segment CB. Prove that angle C is congruent to angle B. So we're proving a theorem that states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So when we look at the statement, the two-column proof, we're stating that segment AD is congruent to segment CB, that's given, and segment AC is congruent to segment AB, that's given. Okay? So, let me back up a little bit. We're trying to make a proof, so, you have to think about it a little bit and kind of develop a plan in your mind of how you can prove, whatever it is that you're wanting to prove, and then write it out. And one way to write it out is with a two-column proof. So the plan is here, I think what we'll do is, okay, this segment AD creates two triangles, two right triangles out of this isosceles triangle. So if we can maybe show that these two triangles, triangle ACD and triangle ABD, are congruent, then we know that these angles, these corresponding angles, angle C and angle B, must also be congruent. So we've looked at what's, the first two statements are given. The third statement says that segment AD is congruent to itself. And the reason for that is what we call the reflexive property of congruence, or just reflexive property for short. And you notice the next statement says that triangle ACD and triangle ABD are congruent. All right, how can we say that? Well, we can say that by the hypotenuse leg theorem. Okay, the hypotenuse leg theorem says that for right triangles, if the hypotenuses are congruent and one pair of corresponding sides are congruent, one of the legs, one pair of the corresponding legs are congruent, then the right triangle is congruent. So now we can say, since the triangle is congruent, that the corresponding angles, angle C and angle B, correspond with each other, are also congruent. We call that CP-CTC, corresponding parts of congruent triangles are congruent. And that completes the proof for number 6.